Robotics. Hello, everyone. Our robot we decided to name Babby. Not affiliated with the typewriter repairman's Babs at all. That was a mistake we made. This is what we're going to be going over today about our robot, different aspects of it, both electronic and mechanical. So without further ado, Ryan.
So the body of our robot, we made it in a rectangular prism using aluminum L brackets. We built this around our enclosure to take advantage of the design flexibility of the aluminum, and we made extra space in the front of our bot for our claw and our winch. And all our mountings are drilled into the sides to take advantage of the design flexibility and to maintain strength. And we made the bolts facing inward, so that way if a diver or someone needed to grab onto the bot, they wouldn't hurt themselves in the process. And the cranial cavity, this is like the brain of our robot. It does all the processing. We hand welded the box that it comes. We did that to ensure the quality, and so we learned how to weld stuff. It holds our onboard controllers and our Arduino board, which controls our forward movement, our up and down movement, and the on winch. And all the wires and the Ethernet tether penetrate via waterproof cable glands. If you don't know what that is, it's like a small hole in the box, and you put silicone on your wire that's going in, then you tighten it up. That way, no water can enter the box.
So we have two arms for our bot, a winch and a claw. So this is the winch. The winch here, the silver part is a aluminum circle with a square cut out of it. And the other part above it, the black you can see, not the bilge pump, but the black is, both of those are spare parts that are lying around our machine shop. So we decided to put those together and increase the cost effectiveness of our robot. And we put those two together to make our winch. The black part above that is a motor with a belt. And that rotates our winch so that we can winch the things that we need to winch. The second part of the two arms is the claw. It's a Vex claw, and it has two modes, open and close. And the blue you see there is a servo that changes these modes, and that's attached up to a bilge pump. And on both of these arms, we wanted to optimize the gear ratio, so that's why we have those two bilge pumps connected to them. And if you can see, it's kind of a little bit hard to see, but from the servo down to there, it's a small to big gear ratio, so that was a really big part of our robot that we wanted to optimize.
As far as navigation goes under the water, because we do definitely need eyes as far as we can't, as pilots cannot communicate with the tethermen, we have 3 cameras on our robot. 2 of them were basic cheap cameras that we waterproofed ourselves. Each of those is in a PVC tubing with waterproofing via resin, and both of those are trained on our manipulations arm so that we can see what we're doing up close to optimize our accuracy. The third camera is an LCA camera that we were able to acquire for free very nicely, and it sits on a platform that pans both vertically and horizontally with the same underwater servo motors from Vex that operate our claw. This allows us to pan over the entire area that we are diving in and view every single aspect that we are going to be manipulating and doing. The Elysium. But wait, what's the Elysium? You've been noticing our creative titles. Well, Finding Nemo fans, the Elysium is the lights of our robot. We're using 2 Green Force Hybrid 2 diving lights. For simplicity's sake, they're simply taped on. They're not connected to our robot in any way. Since we're not going to, in the electrical way, sorry. Since we're not going to be controlling them at all with our onshore computers, we just decided to tape them on, turn them on, we put the bot in, and turn them back off when we take the bot out. They're both halogen bulbs, 18 volts, and they each output 960 lumens. That's a huge upgrade from our last year one, which is no more than half that.
Okay, so we have 5 robotics motors. There's 3 going up and down for movement, and 2 going for forward and backwards. Last year we had them going 12 volts, but it didn't propel us to the water parts of our robot. So that if too much energy is going through, it breaks just the fuse, not the whole thing. We use heat shrink tubing so that the two wires don't touch and make connections that we don't want. And same thing with crimp connections. We didn't crimp them, we crimped them and then soldered them, but to make sure that they were solid connections. And we use breaker fuses for the batteries so that they wouldn't surge through the robot.
Okay, so as the drivers of the robot, it's very important that we're able to efficiently deliver our commands to the robot. Now, what we use to deliver these commands is one, the Xbox controller seen above, and then two, IFI joysticks. The IFI joysticks are simply analog joysticks with buttons on the side. There's a trigger button, there's a thumb button, and then two other buttons on the top to control the movement of the robot. Now, the IFI robot joysticks are used to control the PWM outputs sent to these speed controllers that manage the three different propellers that move up and down, as well as the two that allow you to turn left and right. Based on the controls on these, we can move the robot backwards, and we can also turn the robot left and right, as well as moving it up and down, lifting it, and sinking, diving down. The Xbox controller has an analog joystick over here, which will be used to pan this camera. This camera is managed by two underwater servos, which will have different positions based on how we move this analog joystick, and then we'll tilt the camera up, down, and pan across from side to side. These underwater servos use a PWM input, which is controlled by our Arduino board, which receives a serial communications from our computer, which is linked to the Xbox controller. The Xbox controller interfaces with our GUI program, sending communications through this wire, this green Ethernet wire, via serial communications, and then finally communicating our onboard Arduino, which finally sends the PWM output to our servos, thus managing our camera. The IFI dashboard actually also displays two different numbers, which represent the readings from our sensors. We have a pressure sensor connected to our IFI FRC, and that number is transmitted through our serial tether, a different serial tether, so we can view that number upon the IFI operator interface control board. And as well as using this one solo joystick, we also have the four different buttons here, which manage the opening and closing of this claw seen below here, as well as the turning of this claw from a 90-degree position back down to a 0 position, depending on what type of state we need this claw to be at. And finally, the X and Y buttons can control the rotation direction of our winch operator, so we can either move forwards or backwards based on which button we press and for how long we press it. Now, after our communications go through all these wires, they have to interface with the cranium of our robot. Inside this cranium cavity, we have the 2005 FRC, or the first robotics controller. That controller manages 5 PWM outputs, which in turn respond